So finishing up chapter 13, this is looking at different kinds of data structures, again in Python, and I thought I would just go through a couple more programs that I've written and talk about why I chose different data types. So I went to, as the book suggested in this chapter, I went to the Project Gutenberg and downloaded the textbook, Gulliver of Mars, or Project Gutenberg 604.txt as it's known. And I'm going to do some analysis on this book. So here's the entire book, okay? And the first thing I want to do is just count the sentences in there. And I took what I think is a good approach to this. So I started off, the main program's down here, num sentences equals 0. And there's not a lot of data structure to this, so I won't spend a lot of time on it. But I open up the file. I have the file name up here. So I open up the file as book, and then for each line in book, I go to see if there's an end of sentence punctuation in the line. So count punctuation comes in, and here's the one data structure that I used, actually a string. And the only reason why I use a string is just because it's very simple to use. There are a lot of different methods and techniques that you can use with string, so they're very useful, utilitarian. So I put punctuation count as 0, and then I look at, so we pass in a string. The string is one of the lines from the text, so it might be a line like this. So here's one line, and I go, oops, wrong thing. I go do a for loop looking at every character in that string, and check to see if that character is one of the punctuations. So what I could have done is said if character equals a period, or if character equals a question mark, or if character equals an exclamation point. But it just is tidier to say, hey, is character in one of the things that ends a sentence? And just make that a string. And if it is, then we're going to add 1 to the punctuation count. We're going to return the punctuation count. And then we're going to take that punctuation count and add it to the number of sentences that we've already counted. And then we're just going to print that out. So there's 2,787 sentences in, was it Gulliver of Mars? I'm going to do a slightly different project, as was suggested in the text. And I'm going to do a histogram that measures the number of times a word occurs in this book. Now in this case, I'm going to set things up a little differently, and I'm going to make a dictionary. So the reason why I'm using a dictionary is because I like the way the dictionaries are indexed. I'm going to index this thing by a word. So if the word the occurs in this text, then that's going to become a new index into the dictionary, and then the key value is just going to be the count for the number of times that the word the appears. Now we have to do some things before we look at a word count. There's a lot of different punctuation symbols and other things in here that we need to clean up. Dashes and colons and semicolons and this kind of thing. I didn't count plurals separately. So, actually I did count plurals separately. I didn't count possessive separately. What I should have done is got rid of an end s. That'd be a little trickier to do, getting rid of an end s. So, well, I guess I could have done a right strip s. But anyways, here's all the things that we are cleaning up. I'm thinking as I'm trying to talk here. A bunch of punctuation and possessives, parens, quotes, and there are some, because this is from the Project Gutenberg, there's actually a URL in there, so cleaning that up. Any percentages, if numbers happen to appear, dollar signs. If I was really serious about this, I probably would go in and clean some more things up, but I think at this point I felt satisfied that I had done enough that this would give me a sort of good idea for a histogram for the word count. I did notice there was a couple of more things that maybe could have done better, but like web addresses with a .net and that kind of thing. I could have done better, but like I said, I decided this was good enough. Okay, so this first line of code, actually all this does is opens up the book and goes through and prints each line in the text. And what I've done is clean it up. So I'm giving you a view of what this thing looks like. And then when that's done, then I go through and do a word count with a cleanup line, and I add it to histogram. So let's look at what word count does. And this actually isn't terribly efficient either. I could have easily put this inside this for loop and not done this separately, but, well, that's the way I chose to do it. So let's look at word count. So I start off, I have a histogram defined up above as an empty dictionary. And all a histogram does is just keep track of how many things that you have of each type. So if I look at this first sentence, well, let's see. Maybe the first paragraph. I have one version of this ebook is, oh, here we go. So if I look at this first paragraph, there's a this here and a this here, and I may have missed some, but after that paragraph is read in, I'll have in my dictionary a value, a key for the word this, and the value is going to be 2. So 2 counts of this. So let's look how I wrote that. Well, I'm in the wrong thing. So word count. So again, I started off with a dictionary. And this is passed into a single line from the file. And I split that on space. Then for each word in L, so this is going to give me a list of words. And I check to see, is that word in lowercase in the histogram? And if it is, then I add 1 to its value because I've encountered that word again. If it's not, then I check to make sure that the length of the word is greater than 0, so I haven't got some kind of crazy special characters or something. I didn't do such a great job of parsing those off. And then I want to check to see that I didn't get an integer. So for example, if $100 appears inside the text, so if there was something like this in the text, then what would happen with that is, first of all, we pass to word count line cleanup. So we go up to line cleanup, and it takes that $sign and replaces it with an empty string. So now we would have just 100. And then we come into histogram, and we do a try except, and we try to convert that to an int. In this case, converting 100 to an int would work. And so in that case, we actually don't do anything. If that conversion to an integer fails, then, oh, actually, you know what? I should have float here. If that conversion to an integer fails, float, then we know that we have, well, we have a word. We have something with letters in it. So we add that to the dictionary. In this case, we haven't encountered this word before. We add that to the dictionary, and we have a count of it as 1. I shouldn't have had this as an integer. I should have had this as a float in case we have, something like $100.12. So when that gets converted, again, convert to a float. Okay? So this is the basics of creating a histogram. If you already have the thing in the histogram, then you just add 1 to the count. Otherwise, you check to make sure it's something that you want. In this case, I want it to be a word and not a number. And if that's the case, we add it into the dictionary. So I chose, in this case, and I should be talking about data structures, I chose in this case to use a dictionary because of the way dictionaries are indexed. And it makes it very easy to add 1 to the count for a word. So I just use that word as my index. Instead of having to go through an entire list to find the word and then up the count, I can just use the index. Again, okay, so I guess I've said that enough. Let's run it. So you can see this is the cleaned up version of the book. So I've taken out all the punctuation and stuff, extra spaces, dollar signs, anything like that, percent symbols. There is one thing that I would change differently if I was really serious about doing this word count. When I remove the periods, it takes something like www.gutenberg.net and smushes it into one word. So in my histogram, I'm going to have an entry for www.gutenberg.net. It would have been nice to just have this be Gutenberg, but again, I didn't want to spend that much time. I think we've got the basics of doing the word count. And then if we come down and look at the dictionary, or the histogram, I guess we could call it, as it goes along with us, we see that the word carpeting appears once, fabric appears once, the word closed appears 13 times, playing 18 times, and so on. So again, the whole point when doing this was, why did I choose to use a dictionary in this case? The other thing that's nice about this is notice that I'm making modifications to histogram inside this procedure. So I am adding 1 to a value in histogram that's passed in, and then I'm printing that out back here. So remember that dictionaries are mutable, so those changes that occur inside this procedure actually occur to the histogram out here. That's a desired feature. So that's another good reason to use a dictionary in this case, as compared to something that was immutable. This one I don't actually have any code for, and again, I think the theme here is to just look at, if you have a program, what kind of data structure should you use. So I was thinking about making up a library that stored books, and I could have done this either way, by author here or title here, but I chose to go by title. So I have a library database that has books by title, and then for each title there is a list that's the author, publication date, the publisher, and a price of some sort. So for this database, I chose to use 2 different kinds of data structures. Again, using a dictionary for the book title, because it's just the easiest way to index something like a book title. But then for each book title, I chose to use a list. And the reason why I chose to use a list here is because I always want it to be in the order author, publication date, publisher, and price. So if I want it to be ordered, then using a dictionary in here is not the way to go. I chose to use a list instead of a tuple because I may want to modify this. So for example, if this is like an asking price for the book, then I may end up selling the book for less than the asking price, and I might have to make a modification to this. And so since lists are mutable, it seemed to be the easiest way to implement this instead of having an immutable tuple. So it's all these kinds of things that you have to think about when you're writing a program. The first thing is, how am I going to store my main pieces of data? And that's a big decision to make, and that actually drives a lot of the way that your code's going to go. Okay, all done.